everyone. Today we're doing notes for 6.3 areas under any normal curve. So we're going to compute probabilities of standardized events. We're going to convert an x-score to a z-score and then use the table and our graphing calculators. A reminder, z is equal to x minus mu over sigma, or the value minus the mean divided by the standard deviation. So let x have a normal distribution with our mean is 10, standard deviation is 2. Find the probability that an x value selected at random from this distribution is between 11 and 14. So in symbols, we have that we're finding the probability of x being between 11 and 14. So if we wanted to convert this to a z-score, I'm going to do both of these separately. So we have 11 minus 10 over 2, which is 0.5, and then 14 minus 10 over 2, which is 2. So if I wanted to write this in z-score format, this is the probability that our z is between 0.5 and 2. So to do this in our calculator, we're going to do normal CDF. Our lower bound is 0.5, upper bound is 2, mean is 0, standard deviation is 1. And if we punch this in, we get 0.2858. Sketch what it would look like under the x curve and the z curve. So this one that we did is using the z-score. So let's do the z curve first. So we're going to draw our standard normal curve. Oh my gosh, it's a little wobbly. So here is 0 is our mean. Again, our standard deviation, we go plus or minus 1, then 2. I'll draw out that far. So we're looking to shade between 0.5, so that's right here, and 2. And so if I highlight this, we're shading right here. And so that area represented is 0.2858. So this is our z curve. Now, another way we can do this is we can also do this using the original values without converting to z-scores. So in your calculator, you can also do normal CDF, and our lower bound is 11, upper bound is 14, our mean is 10, standard deviation is 2. Again, this is lower bound, upper bound, mean, standard deviation. And if we punch this in, we get the same exact answer, 0.2858. Now you guys are allowed to do either method, okay, in your calculator. Either one is fine. If you like using the chart, you need your z-scores for the chart method, okay? I personally think these two, the calculator methods, are easier, but it's up to you. Do what's most comfortable for you. So we also have to draw our x curve. So our x curve, we're going to use the values from the problem. So our mean is 10, standard deviation is 2. So this would be 8, this would be 12, go back another one, this is 6, and this is 14. And so we're looking at between 11 and 14. And so we have to shade this. Like that. So you see the area represented is the same whether we're looking at the z curve or the x curve. Okay. The lifespan of a rechargeable battery is the time before the battery must be replaced because it no longer holds a charge. One tablet computer model has a battery with a lifespan that is normally distributed with a mean of 2.3 years and a standard deviation of 0.4 years. So I'm going to write this out. Our mu is 2.3. Our sigma is 0.4. What is the probability that the battery will have to be replaced during the guarantee period of 2 years? So let X represent the battery lifespan. The statement the battery needs to be replaced during the 2-year guarantee period means the lifespan is less than 2 years, or X is less than or equal to 2. Convert this statement to a statement about Z. Go ahead and do this one. So we need a Z-score. So we take our value minus the mean divided by standard deviation. So 2 minus 2.3 divided by 0.4. This gives us negative 0.75. So a statement about Z, we're saying Z is less than or equal to negative 0.75. Again, we're rewriting this statement, but using a Z statement. Indicate the area to be found in the figure below. Does this area correspond to the probability that Z is less than or equal to negative 0.75? So again, we're going to draw a line down here, and then we're going to shade. We want less than, so we're going to shade here below that negative 0.75. And so yes, it does correspond to this. It says use the table. I'm going to do this. I'm going to show you how to do it using the calculator. If you use the chart, you do get 0.2266. In the calculator, we do normal CDF. Now this keeps going forever to the left, right? So I'm going to use my arbitrary low number, negative 10,000. Our upper bound is negative 0.75. Our mean is 0. Standard deviation is 1. And so this comes out to give us the same as the chart, 0.2266. So what is the probability that the battery will fail before the end of the guarantee period? So hint, we're looking at our probabilities here, right? And so it says we're using this number. We have 0.2266. So this is about 23%. So this is some more information about how to use the calculator that I went over. Again, it's just emphasizing it's always going to be normal CDF. It's going to be your lower bound, upper bound, your mean, and your standard deviation. Okay, and again, it's just the same thing that it says here. Okay, if you list those numbers like that, that counts as your work for the problem. Inverse normal probability distribution. When we look up an area and find the corresponding Z values. So now we're working backwards. Sometimes we need to find X or Z values that correspond to a given area under the normal curve. So, example is Magic Video Games Incorporated sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the control system fails during the guarantee period. The research department has done tests that show that the mean life for the computer is 30 months, with standard deviation of 4 months. The computer life is normally distributed. How long can the guarantee period be if the management does not want to refund the purchase price on more than 7% of the Magic Video packages? So we had the mean is 30 months, so mu is 30. Our standard deviation is 4 months, so our sigma is 4. And it says more than 7%. Okay, so if we want to think about what this looks like, here's our picture, and we know that we want our part that's shaded here to represent 7% or 0.07, right? And we're looking for what that Z value is for 7%, okay? So this is an example. This is part of the table spread out, so I could show this to you. So we can see that we have right here, we have these two lines highlighted. And in between negative 1.47, so again, this represents negative 1.47. This represents negative 1.48. in between those two values is the value we want, the 7%, right? But so we're looking at this one is closer. So from the table, tells us our z is going to be the negative 1.48. Now, in the calculator, I think this is a little bit more efficient. You can use the inverse norm function. So in the calculator, it's in the distribution menu. So you hit the second variables. So this is, you hit second, then the VARS. And this is now choice 3, which is inverse norm. Okay, so when you do inverse norm, it asks you for the area. In this case, our area is 0.07. Our mean is 0. And our standard deviation is 1. And so when we do this, we get the same value. This comes out to be negative 1.48. Okay, now, interpretation of the results. So we have a z value now, okay? So our z is negative 1.48. And we want to put this in the z-score formula, and we're going to work backwards to solve for what the x value is. Okay, so remember z is equal to x minus mu over sigma. Again, that z-score formula. So negative 1.48 equals x minus 30 over 4. So I multiply by 4. We have negative 5.92 equals x minus 30. Add the 30, and we get x is equal to 24.08. Okay, so our guarantee period is about 24 months. Now, just like how we can do this with the z-score or values, we can use values just like we did with the other problem. So I can also do this inverse norm, and I'm going to put in my area is 0.07, and I could also put in just my mean and standard deviation, my 30 and my 4. And then if I put this in, it will get us directly to the x value. So this comes out to be 24.10, which does give us the same answer. So again, anytime you're putting in an inverse norm, I'll put a note up here. It's going to be the area to the left, and then your mean, and then your standard deviation. All right, so it says this last example has us find a z-value corresponding to a given area to the left of z. What if the specified area is to the right of z or between negative z and z? So this is the case where if we're looking at the area to the right, this is where you're going to do 1 minus the area to the left to get the value. And if we're looking at the center, this is where you can subtract the two values. All right, so inverse normal probability distribution. This is when we look up an area and find the corresponding z-value. Sometimes we need to find x or z values that correspond to a given area under the normal curve. Use the table in the book or the normal CDF. All right, so this is when we use the table, we use the nearest value. Like I said, I prefer the calculator because it gives you the exact value. But again, I'll check your work using either. So here's another one. It says, find the z-value such that 90% of the area under the standard normal curve lies between negative z and z. Sketch a picture describing this area. So if I want to do 90% lies between negative z and z, notice these values are balanced, right? It's the same distance from the middle, right? Because it's negative z and z. So here's my curve. And I want it so here's negative z, here's positive z, and this part that's shaded represents 0.90 or 90% of the area. So what this means is on the outside of this, if there's 90% in the middle, that leaves me 10% left over. Or that means here and here, I have 5% or 0.05. Here also is 5% or 0.05 because that total under the curve has to be 1 or 100%. Okay, so it says find the corresponding area in the left tail and then use the table, or we can use the calculator. So this is the left tail. This one is the right tail. So if we do the left tail, again, we're going to be looking at the 5% or 0.05. From our table, this comes out to negative 1.645. In the calculator, this is the easiest way to do this. We'll do inverse norm. Again, the area under the left tail that we're referring to this 0.05. Our mean is 0, standard deviation is 1, and so we get negative 1.645. All right, find the z-value such that 3% of the area under the standard normal curve lies to the right of z. So I want you to sketch the area and find this area, which is to the left of z. So we're not finding the z-score yet, we're just finding the area to the left. So go ahead and draw this and answer A and B. Okay, so we're going to draw our sketch, and we said we want 3% of the area under the standard normal curve lies to the right. So here's our z, and we want this part to represent 3% or 0.03. So if we want the area to the left of z, now I'm referring to all of this. Well, if our total is 100 or 1, there's 3% to the right. That means 97% or 0.97 must be to the left. Okay, look up the area in the table immediately below and find the corresponding z. So we want to find what number is closest to 0.97, and that's this one right here, 0.9699. So I'm going to draw a line under it and to the right, and so I have this is 1.8 and then this is 0.08. So this means our z value is 1.88. This gives you the ones and the tenths place. This one gives you the hundredths place. So you put them together to get your z value. Suppose the time to complete a test is normally distributed with a mu of 40 minutes and a sigma of 5 minutes. So our mean is 40, standard deviation is 5. After how many minutes can we expect all but 3% of the test to be completed? So I want you to find this one using your z-score formula. Okay, so we have z equals x minus mu over sigma. 1.88 is equal to x minus 40 over 5. Multiply by 5, we have 9.4 equals x minus 40. Add our 40, and we get x is 49.4. So this is about 50 minutes. Again, the other way we can do this, using the calculator, I can do inverse norm. My area to the left is 0.97. Mean is 40, standard deviation is 5, and this gives us 49.4, the same answer. All right, so now it says use the table below to find a z-value such that 3% of the area under the standard normal curve lies to the left of z. So now we're looking at 3%. This is another way that we can do this problem. So remember, 97 was to the left when we had 3 to the right. We're going to look now for 3% to the left. So we want to find something that's closest to 3% or 0.03. That would be this value here. So I'm going to underline below it and draw a line to the right, and we have negative 1.8 and 0.08. So this tells us Z is negative 1.88. Compare the Z value of part C with the Z value of part E. Is there any relationship between the Z values? Hopefully you noticed, yes. One is the negative of the other. And this is because of the symmetry of the normal distribution. And that's where we're going to stop for today.